So hi everyone. Our world is changing and the change is visible everywhere. So cities are growing, more and more goods and people need to be transported, bringing the traffic infrastructure, the environment and the pollution to the limits. So transformation of the mobility is needed, therefore, who has already started, powered by new technologies and services. So now the presentation will not switch, so it's really fantastic today. Yeah, now, okay, so the mobility of the future will be personalized, automated, connected, electrified, and of course there's enough space for software or the software-defined mobility. So welcome to my talk about the mobility of the future, software-defined, and can open technologies help? So first, I would like to tell you a little bit about the Bosch group. I guess you know all Bosch, so that I will keep that short. Then I will tell you a little bit about software-defined mobility, mobility of the future, and some collaboration aspects. So a little bit about the Bosch group. So maybe you know the Bosch group is divided into 4 main business sectors. One are the mobility solutions, where I'm working in, industrial technologies, energy and building technologies, and consumer goods like household appliances and power tools, for example. So here are some numbers from last year. Means Bosch has around about 400,000 associates in the mobility section, 230,000 roundabout. We, as you can see in the sales aspects, the biggest business will be done here in the business, in the mobility section. We have around about 58,000 people in engineering, 126 manufacturing locations and 68 engineering locations. Here is a video about some global mega trends with innovations and people, society and the environment. So currently there's, I guess, no sound, right? And so therefore I will skip that. I will give the presentation later on, then you can have it for after read, so to speak. So talking a bit about the software-defined mobility. So we have also a project or an upcoming project. It's called the software-defined car or the software-defined vehicle. And currently the software is eating the car, as you may be noticed. So the software-defined car or vehicle describes a shift in the automotive industry away from a hardware-driven development and towards a software-centered approach. So if you look to the past, the software vehicles was or are closed systems as of today, or most of the functionalities in there. So after serious production, software changes are hard to change. Software is hard to change. It can only be done in some workshops or in the garage. So in the future, however, customer benefits will be determined more over the air updates and functions that can be continuously updated than mechanical functions. You know, it's really hard, such as new infotainment functions, security patches, or some monitoring functions. And this fundamental shift from hardware-based to software-centric wheeled IoT device, so the vehicle, yeah, you can call it also an IoT device, requires a real fundamental rethink to meet customer needs. So the software-defined vehicle project provides here an universal end-to-end software platform for seamlessly connecting vehicles to the cloud. And this platform is or was started together with in cooperation with Microsoft, but all OEMs and tier 1 providers can integrate their portfolio of coherent software modules either as a complete solution or as individual components into their own solutions. So the advantages for there, so the pre-integrated software solutions you have therefore enables smooth and less complex over-the-air updates. And as the software architectures of the vehicles and the cloud seamlessly match. So in addition, the software-defined car or vehicle project will develop here new software tools that simplify processes of developing vehicle software and services and thus ensure a greater efficiency. So enablement and the possibility via over-the-air updates over the entire vehicle life cycle significantly shorten innovation cycles and reduce the required development costs. So the software-defined car platform provides here a modular and seamless end-to-end portfolio, including the required operating model that enables any organization to develop and deploy software applications faster and with less effort. So the term software-defined car, that describes a car containing features and functionalities which are enabled by software, and transforming the hardware-based car to a software-centric computer center or an edge on wheels. So vehicles today can already have more than 100 electronic units, a growing array of sensors, cameras, radar and light detection, and ranging LiDAR devices, and up to 150 million lines of software code, and it will still increase. So exactly on the ECU side, so there's a trend to integrate and centralize the software functionalities in high-performance central vehicle computers so that you can reduce the amount of ECUs from hundreds to, of course, a less number. So the benefits of a software-defined car, you can unlock your new safety, comfort, and convenience features. You can receive here updates over the air, for example, some security patches or improvements, monitoring functionalities, and the tuning of some core functional capabilities for the vehicle. Send and receive vast amounts of data to and from sensors and actuators, getting an insight into every aspect of a vehicle, its performance, and its place in the connected ecosystem. And therefore, you will be able to create your new business models. For example, you can buy here a new package like Tesla is currently doing from the OEM store, so that you can have or receive here at the end extra power for track day or an extra range for some longer trips. To build software functions, an efficient software development process is needed to shorten here the development and the deployment cycles. And typically, you have here three options for some software development. So the first one is you can develop the software in-house across most or all domains. You can develop software in-house for one or two differentiating domains and specify or outsource here the development. You can outsource also the complete software development and keep some feature specification, integration, and the validation as an asset in-house. And the approach, therefore, is to create an open technology platform and a community for software-defined vehicle development to accelerate innovation of automotive-grade in-car software stacks for cloud-based vehicle operation and highly integrated development tool chains. And open source can help here in all software development options. And maybe you know it, currently there's also in parallel the EclipseCon, the yearly conference of the Eclipse Foundation, and tomorrow there will be a talk about the software-defined vehicle, where we now announce here some cool stuff. So if you would like, at 3:30 p.m. Central European time, there will be here the talk at EclipseCon. So software for the mobility of the future. So in the meantime, maybe you noticed it as well. Open source software arrived in automotive. And from my point of view, that's really, really cool. So because if you look some years ago, open source and automotive was a no-go. So you cannot speak about open source in the automotive area. And it's still not convenient to talk about that. It's sometimes you have here some blocking things in there. I have here some examples for you to underline that we are in automotive in the open source area there. So for example, here, the Autonomy's Future is open source. The AutoWare Foundation open source some interfaces and tools and some complete software stacks. I came a bit later on to that. Uber open sourced AVS, an open source standard for autonomous vehicle visualization. Then there's Scala, an open source simulator for autonomous driving research. But as it is open source, we can also adapt it maybe to some other needs or requirements. Then there is CARMA from the US Department for Transportation, and they are dealing with vehicle-to-X communication and cooperative driving. Then LG open sourced here a simulator, as well as Tesla published here some code for their Model X, for their Model S. Uber and GM Cruise making here some things open. Continental published their so-called ECAL, an enhanced communication abstraction layer. Audi published here some driving data sets, libraries for machine learning, and also we are their new founded subsidiary Carriot, their so-called functional engineering platform for simulation and testing. So, and therefore, we started with OpenADX. So OpenADX was launched at the Bosch Connected World in February 2018. And we started here with the first activities and the first steps in 2017. We did some workshops and some partnering activities. And during the conference, you can see here Mr. Dirk Hoheisel, former Robert Bosch Group Board of Management. And he outlined here the targets and kicked off the initial test beds, which were worked on in a hackathon format during the 3 days of the Bosch Connected World. So in the Bosch Connected World provided here a good forum for the kickoff with approximately 3,000 participants from various industry working in high tech. And OpenADX was then also brought up in several follow-on presentations by other organizations, identifying it as an important step in the use of open source for attacking complex problems area in the automobile industry. But to be honest, it's not really automotive alone. You can transfer that also on other domains. So developing autonomous driving functionalities, maybe you know that, needs a lot of tool. And often, I guess it's also the same for other domains, for other areas. You choose here the best-in-class tools for your several development steps. And often the tools are not designed to work together with each other, especially from different tool vendors. And to make them work together, you have to build some connectors, and every company is doing that by themselves. And this costs, I guess you know that as well, the industry a lot of time and money. And therefore, yeah, we initiated OpenADX to mitigate exactly this problem and to accelerate the time to market, to share costs and risks, to free up resources to focus on the customer needs by defining here an industry-wide accepted AD toolchain with a high interoperability and an easy access to establish the base for reference architecture. And with the Eclipse Foundation, we found here hosts which support us. And what's also important, therefore, often there's some bit of misunderstanding between the Eclipse IDE and the Eclipse Foundation. Yes, both has the same name, both are under the same umbrella, but both are different things. So please do not mix it up. So I'm currently talking about the Eclipse Foundation. And yeah, the working group has currently the members, Microsoft, Bosch. So I'm steering the steering committee here. I'm the chair of that. We have Denso as a further automotive player in there, AdLink, AVL, ARM, Iteration from Turkey, Eclipse Source. We have Etimis, JSIM, a smaller company from Berlin, Siemens. We have the University of Applied Sciences in Dortmund, and we have Science Plus Computing and two further open source foundations, Open Robotics and the Autoware Foundation herein. So in the Eclipse Foundation, provides exactly what we need, because the collaboration of some companies requires a legal body to have here some imprint of a website, to host your open source activities, and open source managed processes. And yeah, they provides exactly that for us with some working groups, open source contribution management, legal support, an own license, but not only this license is accepted, we can use whatever is a good license, so to speak. And what's really important for us, especially that you are able to talk with competitors, it's the Eclipse Foundation bylaws, especially the Eclipse antitrust policy, which allows me to talk with competitors. And that's really great, because normally that's not possible in other areas. So, and our goal in the OpenADX area is to integrate here a range of existing products into the development suite. And you can see here our blueprint. Yeah, I know it's not 100% complete, so I have later on a bit more complete overview, but this is a first discussion point, or a starting point for discussions, which is currently also agreed by our current members. And the color code here shows many specialized tools from different vendors, and horizontally you can see here some tool chain examples from different companies. Or if you are working in a bigger company, then you can imagine that it's also possible to have different tool chains in the same company. And as companies invested in their tool chains, we are buying licenses of the several tools or training of the employees. We do not want, and we cannot define here the one and only tool chain. No, we focus more here on the tool interfaces, on data models, on standardization, to have here the possibilities to exchange here easily the single solutions, to use whatever you need, whatever you want, and whatever is feasible for your daily work. And I totally believe so an initiative like OpenADX should be inclusive and not exclusive, and this will ensure transparency and make a complex tool landscape more accessible to enterprise users. So it's a win-win situation for everyone in this case. So here you can see a bit of a starting point, or the vision I have. So, for example, you have here the tool chain. What do you want with the tool chain? Of course, you want to produce here, or to create here, some cool software solutions, some cool functions at the end. You know, there's also some open hardware architecture out there, like Core 5, like RISC-V. You have here some open operating systems out there, like Zephyr. And on top of that, in this case, because I'm from the AD world, we have here the software stack from the highly automated driving, or for the autonomous driving, consisting here from with an automotive middleware, having Eclipse Isorix in there, some functional layers like location perception, think, act, and the function on top of that. And you will have here kind of a marketplace in the cloud, because I'm sure we need here the cloud, because looking back to my software development career, you often had a problem that you have to install every tool on your PC. You need here some access rights and so on, and this takes not only hours, it takes sometimes weeks, sometimes a month, till you have everything in there. And if you have here a maintained and hosted tool chain in the cloud, then you only need the access credential and you can start working. And here with the marketplace we would have here in the cloud, then you can use whatever you want. You can click together what you need for your tools, for your software stack, and also vice versa. You can bring in your developed solutions into this marketplace to provide it to other customers. And from a developer's perspective, so with the over-air capabilities we have, you can shorten here the way between the vehicle and the development. So because you are able to access the vehicle directly and get the data, can process that in the cloud and bring that back to the development part. So here you can see a bit more on the vision. So it's more end-to-end. You see here also on the upper left, I know it's very small. Yeah, you can have it also later on. It's just for a short introduction to that. You have here rolling computing center. It could be also a flying computing center or a swimming computing center. I guess in this case it's more or less the same. You will have to bring the data in any way to a backend via over-the-air capabilities, or via Wi-Fi in a garage or in a station or whatever. You have to process the data, you have to label, to augment, you have to map the data, you bring them to a database, bring that to the development steps. And yeah, we have also here the focus on simulation. And at the end, yeah, you will homologate the functionality or the vehicle. The same is here for the software stack. So means, as mentioned, we have here some open activities like RISC-V, Core-V, or some cheap hardware for starting, like Raspberry Pi or some Beagle boards with RISC-V on that. And together with the operating system, yeah, you can use Ubuntu as a Linux derived. And you can bring that also to the cloud, and then you have the infrastructure or the target device as a first step or first sample in the cloud. And there are also some other open source areas out there, for example, for the middleware with the ROS framework, with MicroROS, with Cyclone DDS, with Zeno. Also for the functional layer, there's the Autoware Foundation who provides your stuff. The same for the function itself, in this case, the valet parking. So together with other open source initiatives, we as OpenADX lays the foundation for some safety and standardization. So OpenADX currently in this picture is in the middle. Yeah, the reason for that is I draw this picture, and as I'm from OpenADX, I thought about where are my interfaces to other working groups, and there are more automotive working groups here in the Eclipse area, like OpenMDM handling with the measurement data, Open Mobility for open traffic simulation, OpenPath for some virtual simulation coming from accident research. And there are also some public funded projects out there which we consider for our work, because our goal is not to reinvent the wheel, because we will use existing solutions. And maybe you know it, the wheel is yeah, sometimes reinvented more than twice or three times. Often there is the same solution, or more or less the same solution, multiple times out there. And with App4MC, for example, we have here an exchange platform for timing and performance simulation. Eclipse Cuxa is an automotive platform, and Panorama here is it's also an Eclipse project or working group. It's for design efficiency, and there are also some further automotive projects out there. And we are working also together with some standardization bodies like ASAM, and today with Accelera, maybe more in the future, with Modelica, because we are using also the FMI standard, and also with some open source or yeah, more automotive standardization bodies like Covesa. And I try to get more involved into the open hardware group to bring there also the stuff further. So my wish, my dream at the end is to have a complete software development kit. So with an open hardware, with an open software, with an open tool chain, to have here the possibility to start easily. So here are the current projects we have currently under OpenADX. So you can see two are more or less under the area of simulation. It's Eclipse Chloe and simulation middleware, and I will explain it a little bit more in detail later on, but not too deep. Eclipse OpenMCX, it's for co-simulation based on the AVL Model Connect framework. Eclipse App4MC, Eclipse Isorix, Eclipse Cyclone DDS, and Eclipse Zeno are more in the software stack on the ECU side. So we have here, we approach two aspects. Means not only the tool side, also the software stack sides, where we provide here some functionalities. And one use case I will present to you later on. So to have a rough overview what we are doing with our major initiatives here, we have here Chloe in the middle, because it's a simulation middleware, and Chloe connects here the real simulation engine, could be a proprietary or could be an open source simulation engine with the software you want to test, providing here a user interface to see what happens during the simulation, and to adjust here also some simulation parameters to activate here also some software function. Chloe is a kind of an abstraction layer which connects that stuff. And in this case, yeah, we have here on the right side a software you want to test. It's also the AD software with some open source stuff in there. It's Eclipse Isorix, a middleware with a serial copy shared memory approach, which is optimized here for huge data inter-process communication. Maybe it's also relevant here for some other stuff beside here automotive. Yeah, you can use it wherever you have a lot of data to transfer in this case. And if you would learn more about that, so the first step is here the overview about Eclipse Chloe. Here I have the link to GitHub, or you can Google for that, or with whatever search engine you want to use. So here you can see a little bit of Chloe in action. So with a use case in mind to have your kind of simulation as a service. So no fear, there's no sound behind this video, so I will make the sound for you, so to speak. You can see here the scenario which is tested above that current 3D engine rendered scenario. You have what the software really sees here. In this case, the green box is the ego vehicle. You just saw that there is the possibility to adjust here some simulation parameter. Here you can activate here some software functionalities, and you can see what's happened here during that simulation. The advantage of Chloe is that you can containerize it, and you can run as many Chloe simulation, so to speak, in parallel as you have machines for that and resources. So it's, yeah, maybe you know it for autonomous driving. The traditional testing methods won't work anymore, so you have to drive billions of kilometers, which is not possible. And this is the reason why here some parallel processing things helps us a lot. So here it's Eclipse OpenMCX. So we had a short presentation also during the EclipseCon. If you want to learn more about that, here are the information for that. So it's roughly part of the Model Connect framework, dealing here with some standardized interfaces like FMI, like DCP, like SSP, and it's under the umbrella of OpenADX. So here you can see a bit about Eclipse Isorix, the shared memory approach. So the main advantage is that you do not have to copy messages anymore. So you will have here some memory chunks, and the publisher writes data to the package. And the next step is not to copy that stuff, it's handle the references. Everyone who needs the data have the possibility to access it directly without copying, and it's really a big advantage for big data communication stuff. So here with Cyclone DDS, we did also the next good move, so to speak. Cyclone DDS is based on it's an open source implementation of the OMG DDS standard for data sharing technology designed to secure platform neutral interoperability. And it started as an IoT project, and now we have it also in automotive. And that's really cool. So you can see you can adapt that to the needs you have and bring things together. So here you will find more information about Cyclone DDS. You can download here also the code, and you can start here with developing. With our OpenADX website, we try to bring things together to have here an information portal where you can find information about autonomous driving, about toolchain proposal, cookbooks and how-tos, and also non-proprietary solutions and initiatives are welcome, because we do not want to reinvent the wheel a second time. We want to integrate all solutions which are out there, which are helpful, which can bring us further. And now I will come to one of the cool use cases we have. So last weekend there was the so-called India Autonomous Challenge, where race cars made a race on the famous Indianapolis Motor Speedway, and the hardware, so the car, was identical for everyone, and the only difference was in real the software. The teams, all university teams, can use whatever they want. Typically, they decided for ROS open source with OpenADX on board. So we can see here the logo. So they used Cyclone DDS with Isorix built in and Eclipse Zeno for vehicle to infrastructure communication. So now you will miss a bit the sound of the motor. So this was in an early stage where they learned to drive autonomously on the Indy Speedway. And yeah, as mentioned, last weekend there was the race, really impressive, was also with a live stream. And you can see there, yeah, what is possible in the autonomous world, what is possible with open source. So the winning team, the Technical University of Munich, they open sourced everything. So you can download the full complete stack. And yeah, if you want, you can also build up your race car if you like. Here's some further impressions about the teams. So they started with 41 racing teams. In the final competition, they had 9 teams, and the final shootout was done with three teams. And you can see there's no space here for the driver. It's fully equipped with sensors, with computing power. Yeah, it was a cool event. So what we want to do with OpenADX is to build here development workplace, to fulfill our program plan, and to build here in the area of simulation and demonstrator. So what can we do else? Maybe you have also some input for us, so let us know. But first, to stress here a little bit the co-simulation demonstrator. So what we want to do is, yeah, we will bring together different simulation things, mostly out of the open. We want to bring them together to see what is the real problem in the area of bring that together, what is missing, does it work as we think about, and therefore also highly welcome, help us, bring in your ideas, because from my point of view, or I just had a look on what is co-simulation. And so here I have also the definition and the link where I have that, yeah, where I copied that. So co-simulation at the end is the joint simulation of loosely coupled standalone sub-simulators. So I just go back to the slide before. Yes, we have here some loosely coupled simulators. And the co-simulation algorithm takes care of time synchronization and interactions across the sub-simulators. The interactions between these sub-simulators are only synchronized at discrete communication points, and the sub-simulators are assumed to be completely independent. So it's also like black boxes, and so I will show you here also some example. Maybe you're also familiar with that. So for example, also a good example from the maritime area domain. So it's the open simulation platform where you have a standardization, a co-simulation interface, FMI. So we in the automotive area use often also FMI. So therefore we have one common, I would say, transport layer, but the several use cases or parts are different here. Then one example out of the open, it's Eclipse Mosaic. It's also a simulation runtime infrastructure with federation management, with time management, with interaction management, and also a lot of input there. Then in the India Autonomous Challenge, they used also simulation. So not really a co-simulation, but if you look at a car, you need there, or in the vehicle and the system development, you need there also co-simulation. So then I looked, so what are the real common requirements here for co-simulation or for simulation in general? So you need standardized interfaces. You need simulator coupling. You have to handle here the simulation lifecycle. You have to start and to stop some simulators. The interaction between simulators have to be managed, and the time management to synchronize the event processing in all simulators. And most of these requirements are, from my point of view, please correct me if I'm wrong, are non-differentiating. And so therefore it's in part for an open collaboration from my point of view. So we often talk here, we talked often about cross-domain simulation. And here I have here some matrix. I guess you know that from last year's DVCon. We have here some cross matrix because, the simulations are one of the cores of the development process, and you have here the simulation over the complete life cycle. Independently, if you are in the semiconductor area, independently if you are developing robots, if you are automotive, in the avionics or in the defense and space area. And every industry develops their own system simulator, solving more or less the same problems. And they have the different standards. Sometimes they are the same. So you can see here they have an operating system. Often you are based on some kind of Linux. You have here communication layers like a DDS and the simulation engines with different standards. Yeah, from my point of view, there's a lot of things you can bring together. And the simulations and the models across multiple enterprises are often reused in different contexts. And the current existing standards, they are domain and industry specific. And from my point of view, often dealing with the same problem space. And but they cannot combine easily. So yeah, and they often do not address multidisciplinary aspects of the system simulation and modeling. So hardware, software, mechanics, electronics, and there's a need for alignment. And from my point of view, let's start and bring this together, and in the best case in the open. So, and why in the open? Why open source? So let's talk a little bit about that and the motivation. So often you think, okay, that's really paradoxical, but I'm totally convinced that open source is currently the best way to reach a wide range of business goals. So for example, have a look on the left side, how open source works for companies. So base is to partition software into differentiating and non-differentiating parts. So the non-differentiating parts, they can be open source. The differentiating parts should stay proprietary, or you can use it also as a strategic move to open them to achieve your special goal. And the question whether a piece of software is non-differentiating or differentiating can often depend here also on the time. What a USP is today can maybe tomorrow, maybe in a couple of years, be a non-differentiating software. And shared development here means in that case, you work together, you give and take here software out of a common repository. On the right-hand side, what you can gain here from open source, above all, it's efficiency in various dimensions. So open source allows you an agile collaboration with a minimum of formality, as opposed like in consortia. The visibility to many eyes increases the the quality. So I see that with some developers, so it's a real big difference if you do the software in-house and no one else can see the software, or it's open and everyone can have a look on that. So it's really the honor of the developers you are touching here. So the contributions from many partners increases also the development speed and share here risks and reduces costs. Maybe you know also the software industry often tend to the winner takes it all, and open source helps to minimize here the dependency on suppliers and can break or prevent here some proprietary monopolies. So the experience with other open source projects has shown openness accelerates here also market penetration, or can accelerate the market penetration, and sometimes even creates new markets. And that's really important and really exciting from my point of view. So, and some characteristics here for open source software is often the security bugs in open source software get fixed immediately because there's a big community who has a look in that. So key open source software projects has a lower error density than the proprietary average. Open source can be modified to suit your needs. You do not have to reinvent the wheel. You can just use that and adjust it. There's no restriction regarding the use cases, regarding regions, regarding business models. And really important also, the open standards allow interoperability with other businesses, computers, and users. So you can do here also some cross-domain things. So the visibility of the open source code empowers also you to audit the product, because it's open, it's traceable, and you have typically no software fees, no cost per unit raise. It's not completely for free. You have to invest in there, but it's a total other amount, and it's immediately available in the community. So if you think about how to monetize, then if you're doing everything open, so there are currently a lot of established business models out there. So for example, you can build here additional services around open source. You can share here development costs because you do not have to do everything alone. Like mentioned, with a simulation as a service, you can also charge for that. You have here some possibilities for dual licensing, some selling exceptions. You can do it via membership or donations, via crowdfunding, advertising. So that's not typical made for big companies, but update subscriptions is just one further possibilities. And what is currently emerging in the OSS open source area, it's to sell here data, user data or user-generated data for further use, or the software certification, which is also done by some companies. And the value creation, sorry, I was a bit too fast. The value creation is, from my point of view, not really done in the software. It's more in the capability to solve your problem, or to solve your something in the problem space you are working in. So typically, the customer buys not your product because you have here software XYZ in there, so because the product solves the problem the customer has. So the open source value stream. So you have here you start here with two parts, so to speak. One is the giveaway part, where you allow others to use your IP and patents for exactly this special use case or this special area. And you also can enable them to make their own business, because the source is open, it's free, they can use it. And then you have the blue part, where you can earn your own money. So, and with contributions to open source projects, you extend here the area of giveaway. But if you are in the pole position, you can steer here the community, you can pave here the path which is feasible for you. But also other can extend here the giveaway section. And then you will come to the point where this business model is under threat. And then you have to adapt, to change your business model in a continuous approach to get money back here for that. So just to sum up a little bit, open source software is more and more gaining traction, and not only in this automotive industry. It minimizes dependencies on the suppliers. It increases the quality, really important point, through a broad testing reviews, with scaled attention, with a broad expertise. It enables risk sharing and cost reduction. And it's really essential for the success of partnerships and consortia. So from my point of view, the future of not only mobility is software defined. So it's more or less for every domain we have. And open technologies, open standards, and open source helps to collaborate in a changing market. So let's work together, join forces, bring simulator stuff, standards together, and let's see where we came out therefore. So thank you for having me. So here you can have also later on most of the links we have here. And you can ask me anytime, send me a mail, join us, come to the OpenADX working group, come to the website. And yeah, now I'm open for questions. So thank you all.
Thank you, Andreas. And I think we managed in the end to give the presentation, which is great. I think there are questions in the chat. I'm not sure whether you're still in Zoom. Otherwise, I can read them out loud.
Yes.
And
now I use the second PC. So one of the problem makers, so to speak. Sorry if I do not look now into the camera, but then it's a bit easier to follow on the questions. So where
I think I see one question of, let me read that for you. There was one question from Bas Arts from NXP. The ecosystem of standards, tools, tool chains, simulators, hardware, software, collaboration possibilities, etc., seems quite overwhelming. Yes, this was a long sentence. For future engineers, would you recommend to focus on specific parts or to focus on building knowledge regarding the overall setup and or system?
So from my point of view, it's start with a kind of a research. What is out there, especially in the development area. So you have often not to start at scratch and then figure out what is coming in your company, what are the differences in the standards, for example, and let's work on that and try to collaborate, because there are a lot of people out there who are trying to solve the same problem.
Okay.
So just, if this answers the question, so just looking if there is, okay, sorry, no. Yeah, sorry. Go ahead, please.
Yeah, I do not see other questions, but perhaps there are others. So let me also reach out to Laura. Did you receive other questions? Otherwise, feel free to give your question, add your question to the chat or to the Q&A box. We have time for a few more questions. We're just eating some time from the closing ceremony, but those guys will stay around for a while, I guess. So we have another question. If you use the software for your product, how to deal with versioning? I guess there is a lot of versions for. I guess there are a lot of versions for a software. Yeah. So deal with versioning in general. How do you deal with that?
So for software, we use typically GitHub, and therefore then you have here a kind of versioning, and you have also the possibility to plan here some releases, to do some releases, so that you have at a certain point your fixed configuration, so to speak. which everything fits together in this special release. So if you think on automotive stuff, where you often have some different approaches for software versioning, for software configuration management. So currently there's often also the approach to jump to GitHub Enterprise, to bring GitHub also into or behind the firewall of every company, to work that with GitHub, because it's more easy to handle than the former, often also in-house developed configuration systems, and that helps a lot. If this answers your question.
Otherwise, we will get a pop-up, I guess, of Silva Strehel, who gave the answer. More questions? Otherwise, I think we can close the session. Thanks a lot for your keynote. I think it was nicely connected to the conference and to the other keynotes we have seen during the last couple of days. So thank you very much. And I think we are heading over to the closing ceremony. I think I would like to invite everyone in the call to pick up your avatar, and let's meet like we normally do in the in-person event. Grab a beer and let's do the celebration on the best paper and poster awards. So we get ready for that session. So we invite you to join us in the conference room, in the virtual rooms. Thank you for attending the keynote, and let's move to the closing ceremony. Thank you and bye-bye.
Thanks.